So I'm thrilled to be here tonight representing the dental school to tell you about the three intersecting worlds of science that I inhabit. And I will tell you about the lessons that I learned in each of those worlds. And I'm going to tell you three stories, kind of mini-moths. And the first story I'm going to talk to you about is actual discovery, what we do with stem cells in our lab. My lab at the dental school, where we do pretty remarkable things with stem cells to develop treatments to treat a variety of diseases. Then I'm going to tell you a different story. This story is going to be about how I became a citizen scientist, how I began to realize that the impacts of what I'm doing in my lab actually resonate in policy, in ethics, in moral issues, and how I began to realize that and what an impact that made on me. The third story I'm going to tell you is how I took that understanding and realized that I wanted to empower undergraduate students to also be science literate, to find their voice in the conversation about science, and that Tufts graduates would walk out the door knowing that scientific knowledge and being part of the science conversation is absolutely indispensable. So I call all of this bringing science to life. So I'm excited to tell you how we bring science to life in the laboratory, because we can do some really cool things with stem cells. But what really excites me now, and I think this is kind of a Tufts-specific identity, is I can go in as a dental school faculty member, collect faculty members from around the university, and bring science to life in the minds of a freshman Tufts student. That's a wow moment for any teacher. So let me tell you about the first story about stem cells and tell you what we can do in the lab. Here's a patient. We can take a biopsy, a small biopsy, from the skin of a patient with a chronic disease, grow the cells in a plastic dish, the green cells, and then we can push those cells back into an embryonic state, turning biology upside down, essentially reversing human development, going from an adult cell back to a stem cell that has the properties of a cell that's present in the human embryo. Last year, this technology was awarded a Nobel Prize in Medicine, and we do this in our lab routinely. So once we have these stem cells, which have the same potency as a cell from a human embryo, we can push those cells into any specific cell type that we want to. And as we do that, the cells that we took from the patient who have that chronic disease begin to recapitulate the disease properties that were manifested in that patient. So we have a way now of correcting those cells, of rejuvenating those cells, and ultimately the hope is we can return these back to a patient to treat that disease. Essentially what we're doing by this technique of pushing cells back to an embryonic state, or what is technically called reprogramming, is to reboot the hard drive of these cells. And when we reboot the hard drive of these cells, we have opportunities to allow them to become rejuvenated and to do remarkable things. What I do in the lab is I make skin from these cells. And we make skin cells from embryonic-like cells to treat human disease. Now, please don't tell my wife that I'm carrying skin in my pocket of the new suit that I bought this week. But I just wanted to show you what this looks like. So here we have a little plastic dish. We have skin cells that are growing as skin in this little insert on this plate of nutrient broth. And this is skin that we make in the lab from its component parts. And I should tell you, we make it from foreskin cells, which have a lot of stem cells in them. Sal, I knew it. Thank you very much. So here's skin. We made this in the lab from scratch. You can see its tensile properties. I'm pulling at it, I'm tugging at it. Looks like cellophane, but this has all the biological properties and function of human skin. And what do we use this for? We actually can layer this on top of a non-healing wound or on a gum defect. And this does not take, but it actually secretes products that cause regeneration of the tissues underneath this essentially biological Band-Aid. So I will save this and pass this around after dinner and tell you that it's pretty incredible that we can do this in the lab. I'm amazed every time I look in the microscope and see that we can make skin just like that. So now I'm going to tell you about the second story. Because from everything you've heard me say so far, you're probably imagining that there's a clear path forward. Stem cells are the future of humans' therapeutics. And actually, that's not the case. Because there's actually a cloud hanging over the field of stem cell research. And that cloud is there because even though we have these wonderful cells that we can push back to embryonic-like states, we still need to use cells derived from human embryos as the gold standard for understanding how to use these very potent stem cells for healing. But there's an ethical, moral, legal controversy that's been raging in this country for the last decade. Started in the Bush administration and continues till today. Because harvesting embryonic stem cells from a human embryo destroys that embryo. This culminated in August of 2010 when a district court judge in the District of Columbia ruled that embryonic stem cell research is unconstitutional. Now, I had a transformative Tufts moment. I was so focused on the science that I didn't realize that there was a political agenda here, and an ethical agenda, and a legal agenda, and a moral agenda. And I said to myself, I need to be part of this conversation. I need to be a citizen scientist. And I acquired a new understanding of how I needed to think about my responsibility as a scientist. It extends beyond the Petri dish. And I thought, I need to share this understanding. Who can I share this new understanding with about the impact of science in society, the impact of our conscience and capabilities? And I thought, I want to share this with first-year college students. They need to hear this. They need to understand what I just learned and to share that understanding with them. So I developed a freshman seminar. And I call that freshman seminar Science and the Human Experience. And this is really the third story I want to tell you. A class where students can grapple with some of the issues, the compelling issues of the day at the interface of science and society. Questions about when life begins, what defines a person, what is personhood, do I really want to know my DNA? And if I know my DNA, what would I do with that information? It's about building science literacy, understanding the impact of science in our daily lives in a very personalized way through the lens of a 19-year-old. And as these students began having these conversations, they began grappling with the uncertainty of science, with these gray areas. And as they had this conversation about the gray areas, they started talking more openly, and a whole world opened up to them. They started looking at themselves through a different lens, because if they were uncertain about what we know and what we don't know, they could share a conversation that would cross a spectrum of values and beliefs and allow them to embrace positions that they had thought were previously distant from their own. In a way, these students were able to find their voice in this public conversation about science. One way they found their voice was by writing op-eds. And here's an example of an op-ed booklet that our students published, in which each one of them was able to articulate something that they were passionate about through their unique worldview about science and its impact on their lives. But instead of me voicing an opinion about the course, let these students in their own voice tell you a little bit about what they experienced. So I'd like you to meet three students from last year's seminar, Science and the Human Experience. First, Nive, who will tell you a little about a humanizing experience that she had in the class.
We had this one speaker who talked to us about how humans view other humans. It changed the way I saw other people. Someone with a condition like Parkinson's, it's very, very hard to tell how they're feeling. We can't empathize with the way they can express themselves. It really helped me empathize with a broader range of people.
Here's Maggie, who was able to bring in part of her culture into the science conversation.
I came to Tufts, and the reason I chose Tufts is I love Arabic, and I came to be an Arabic major and do IR with Middle East focus and just study the Middle East and Arabic. That's what I wanted. Coming into this class, I can remember being so happy that he let me bring that into the class. When we were discussing stuff, he let me say I come from this background and this is my opinion on it, or this science topic, I'm Lebanese and this is how our outlook may look.
And finally, Ariel, who was able to find some ethical guidance in her thinking about her future profession.
I think freshman year is a very transitional time. People are still unsure of where they want to go and what they want to do. So I think by being in this class, it helped me realize that when I'm going into medicine, I want to be able to understand the ethical side of things. I want to be able to discuss things with people who may have different beliefs or different interests than me.
So those are just 3 voices from the class. But I can tell you from the outcomes of the course that what our students learned, and what we learned also, was that our students discovered that science is approachable, it's accessible, it's relevant, and it's personal. And it made all of the faculty from around the university who taught this course realize that perhaps it's time for a mandate in science literacy. We have multiple literacies. We have reading literacies, writing literacies, math literacies. But how about learning literacy so that you can become empowered in the civic conversation in a way that will allow you to have a civil, respectful dialogue about these potentially polarizing and contentious issues? So the lessons I learned, I think, are tough, specific lessons, in that here I am, a dental school faculty member, in my lab doing research, and appreciating that indeed, while the science is the epicenter, rippling out from that science and from that discovery is the broader impact of science that we can bring to bear on the Tufts community, to our students, and to the greater good in society as a whole. And ultimately, I realized that to teach the value and consequences of science is to learn what it means to be human. And teaching an undergraduate class of Tufts freshmen is indeed a very humanizing experience for all of us. Thank you very much, and I look forward to taking questions.